Hello, this is Jeremy, and in this example, I'm going to go through how to find conditional probabilities, specifically when you already have data set up for you. In other words, you have some kind of survey data or something like this. So in this particular example, we're given data on a survey of employees at a company and whether they're interested in additional training on our online system or not. So focusing on the questions that's asked and how we write this with notation, because that's going to help us out later. It says, what's the probability a randomly selected full-time employee is not interested in additional training? Now notice what's happening here. Probability of randomly selected full-time employees. So we're not looking at the big group of all employees anymore. We're specifically looking at full-time employees. The way the notation works for conditional probability is what you're trying to find goes first, and then you have a line that represents given if you're reading it. And so we know the person's full-time. So essentially, we're trying to find the probability of something given that they're full-time. And what we're trying to find the probability of is that they're not interested in additional training. So I would just write not or something like that so I know what I'm talking about. So again, the way I would read this is probability of not interested given full-time employee. Now, the idea with this type of conditional probability is if you're given the data already, you actually know how large the space is. You're not looking at everybody anymore, which is this 287. That's everybody. We only want to know about full-time employees. And so that would be this group right here. Full-time employees are this group, so I'm actually picking from that group. So there's a total of 142 full-time employees. So essentially, I zoom in what I'm looking at. Now, out of that group, 76 are not interested in additional training. So this probability would be 76 out of 142. And of course, you would either simplify this or better yet, write as a fraction or percentage, right? I won't be going through that. I know you know how to do that. But in general, most people would like to see one of these forms of a final answer. So this wouldn't be my final answer, but this is how I get there. Focusing on the probability, though, once again, it's the group you know that you are looking at that you zoom in on. So let's try another one that's worded a little bit differently. So in this particular example, I'm told if an employee is part-time, what's the probability he is interested in additional training? So we're saying suppose the employee is part-time. So this is probability of something given that they're part-time. And what is the probability that we're trying to find? Interested in additional training. So I could just say, yes, they're interested given they're part-time. So just as before, I want to focus in on part-time. And I want to say, okay, that's going to be out of 145 because there's 145 employees that are part-time. How many of them were interested in additional training? It would be 83. And so again, once, to get a final answer here, I'd write it either as a percentage or a decimal most likely. Well, notice here that this is like the previous one, right? There's other ways that I could ask these questions, and sometimes they're simply written. For example, I could say, what is the probability someone is part-time given they are interested in training? And so this is actually the reverse. What is the probability they're part-time given they're interested in training? And you would think that these would be somehow obviously related to each other. But what actually changes here is now what the group that I know about is, yes, they're interested, and I'm only looking at employees that are interested. So I'm looking at this group now, which has a total of 149. So this is out of 149 now. And then I'm curious how many of them are part-time. And so there is a bit of a repeated number, the 83, right? But it's not as obvious of a relationship as you would think. So the orders are very important here. And so the second part is always what you're given, what you know, and what you're trying to find. Now, finally, this conditional probability idea can be used to talk about independent events. So you may say, well, it shouldn't matter if an employee is full-time or part-time as far as determining if they're interested in the training or not. Or maybe you have an argument that it should matter. But when I ask if they're independent, I'm actually asking a much more specific question. I'm saying in this data set, can you say that one event influences the probability of the other? Well, in general, for independent events, we can say A and B are independent if the following is true. That if you ask me, what's the probability of A given B, and they're independent, I don't care that B happened, I get the same probability as if it didn't, because the fact that B happened didn't influence the probability of A. That's the idea of independence. So what I need to check when you ask me a question like, are the events an employee is full-time, an employee is interested, or independent, I need to check, is this true? Can I say this is true or not? So one way to do that is to start out with the first event and say, okay, let me find the probability an employee is full-time, and I want to compare that. Does it equal, so this is a question mark because we don't know, the probability, so I got this part, and now I want to say probability of the first event, so full-time, given, and then whatever I'm trying to compare it to. So they're interested in additional training, so I'll call that yes again. I want to know if these two things equal, and they have to exactly equal for me to say they're independent. If they don't equal, I'll say the two events are dependent. Okay, probability of full-time, there are 142, so we're looking down here, 142 full-time employees out of the 287. So we want to know, does this equal? And now full-time given yes, so the known event is yes, they're interested. So I'm looking at this group right here, they're interested. And so that would be a total of 149. And how many of them are full-time? It's 66. So the question is, do these two equal 100% or not? And they do not if you check in your calculator. So these are not equal. So I would say the events are dependent. So again, conditional probabilities, there is a formula you can use to find them, but a lot of times you don't actually need the formula when you have data set up like this. If you can just think about it logically and say, what group do I know about, and zoom in your probability to that.